Hey guys, welcome to part 3 of the differentiating exponential and logarithmic functions. In this video, we're going to differentiate the logarithm functions. So if you haven't watched the video about the log laws and you've forgotten what the log laws are, you should probably go watch that. Otherwise, this isn't going to make a whole lot of sense to you. Anyway, let's get started. So recall that y is equal to log to the base of b of x if and only if b to the power of y equals x. And so that means that the logarithm to the base b function is actually the inverse of the b to the power of something function. So that's kind of an important detail. What we're going to do now is we're going to define something called the natural logarithm. So the natural logarithm, y of x, is equal to log to the base e of x, where yes, that is the special number e from the first and second video. So log to the base e of x, and it's usually written as ln, which stands for natural log of x. So y of x is equal to natural log of x, and of course this is true since e is just a number. This is true if and only if e to the power of y of x is equal to x, same as before, kind of. All right, so now let's let z of x equal e to the power of y of x, and we'll call, and of course this is still equal to x, and we will also let u of y, so u is a function of y, and u of y is equal to e to the power of y. And what that means is that z of x is actually equal to u of y of x, because e to the power of y of x comes from putting y of x into u. You get e to the power of y of x when you do that. So z of x is equal to u of y of x. And from the chain rule, we therefore know that z prime of x is equal to u prime of y of x times y prime of x. So u prime of y of x times y prime of x. Well, we just spent the whole second video differentiating the function u of y. So the exponential function, when you differentiate it, you just get the same function again. And that means that u prime of y, is just equal to y. Sorry, is just equal to u of y, which is equal to e to the power of y. So if u of y equals e to the power of y, u prime of y is equal to e to the power of y. And therefore, u prime of y of x is equal to e to the power of y of x. Now y prime of x is the thing we're looking for. Y prime of x is the thing that we're looking for. And e to the power of y of x, by the way, is equal to x. So this whole thing is equal to y prime of x times x. Okay, well, we're nearly done because we just differentiated this side of our z function. We said z prime of x is equal to e to the power of y of x differentiated, and it turns out that that's equal to x times y prime of x. Well, that's all fine. We also know that z prime of x, and I'm running out of space here, z prime of x is equal to 1, because z of x is just equal to x, because z of x equals e to the power of y of x equals x, and therefore z of x equals x, and so z prime of x has to be 1, because x changes at a rate of 1 unit per 1 unit. So z prime of x equals 1, and therefore y prime of x times x is equal to 1. And therefore, that gives us the answer we're looking for, that, in fact, y prime of x is equal to 1 divided by x. And so that's the derivative of the natural logarithm function. Let me restate that up here. Y of x equals natural log of x, which is log to the base b of x. Then we know that y prime of x is equal to 1 over x. And just knowing this detail allows us to differentiate any logarithm to any base that we like. Because, as we found in the last video, if I take log to the base b of x, well then I know that that's equal to log to the base a of x divided by log to the base a of b. Well, that can be any number we like. That a can be any number we like. So I can take the number e. So log to the base b of x is equal to natural log of x, in other words, log to the base e of x, divided by natural log of b. And since b is a fixed number, so is natural log of b. And hence this is equal to 1 divided by natural log of b times natural log of x. And now if I want to differentiate this, so let's say I say y of x is equal to natural log is equal to log to the base b of x, then that tells us that y prime of x is equal to the derivative of this thing. Well, this is just a constant number, so that hangs out there, it doesn't change. So y prime of x is equal to 1 divided by natural log of b, and then we just differentiate that part. Well, we already worked that out. It's equal to 1 divided by x. So y prime of x is equal to 1 divided by natural log of b times 1 over x. And when you multiply fractions, you multiply top by top, bottom by bottom. So this is equal to 1 divided by natural log of b times x. Okay, we can also do similar kind of tricks, playing around with certain stuff to differentiate any exponential function we like. So suppose we got y of x equals a to the power of x for some base a. Suppose we want to differentiate that. Well, we can do that just from the knowledge of the derivative of natural log and the exponential function with base e, because we can take log of both sides. So y of x equals a to the power of x if and only if natural log of y of x, I'm just not going to bother to write the x, is equal to natural log of a to the power of x. Well, that's true if and only if natural log of y is equal to x times natural log of a by the power rule. Therefore, if I want to differentiate both sides, I can by the chain rule. So here's y of x inside this other function. If I want to take the derivative of this thing with respect to x, well, first I have to differentiate that natural log function. So differentiating both sides, we have 1 divided by y, so that's the derivative of natural log of y, times the derivative of the inside function, y prime of x. And we know that this is equal to the derivative of this side because these two things are equal to each other, and hence when we differentiate them, we must have equal derivatives. So the derivative of this side, well, this is just x times some constant number, natural log of a. So the derivative of this side is just natural log of a. And therefore, timesing both sides through by y, we have that y prime of x is equal to natural log of a times y. And of course, y is equal to a to the power of x. So given any function, any exponential function, y of x equals a to the power of x, we can differentiate it, and the derivative is y prime of x equals natural log of a times a to the power of x. And of course, since this is worth noting as well, since natural log is equal to log to the base e by definition, if we take a equals e, what's going to happen? We're going to have natural log of e times e to the power of x. And well, natural log of e by definition is just 1, because this is log to the base e of e to the power of 1, and by definition that's just 1. So this also includes our previous result, although we used our previous result to get to this one. Just pointing that out so that you know they're not different, they don't contradict each other at all. Okay, I guess that's it for this video, and yeah, I guess that's it for this section. Thanks very much for watching. Don't forget to check out the notes and do those exercises at the back of the notes. Make sure you're familiar with the material involved. You don't need to know all the really complicated stuff in the first video about expanding out all those nasty brackets, but you do need to know the main results. Okay, you need to know that the derivative of e to the power of x is e to the power of x itself. You need to know that the derivative of this thing here, a to the power of x, is equal to natural log of a times a to the power of x. You need to know the derivative of natural log of x is equal to 1 over x. And you need to know that the derivative of log to the base b of x is equal to 1 divided by natural log to the base b times x. Well, divided by x. Anyway, you need to know those results. Thanks very much for watching. See you guys next time. Bye.